Good morning. We are asked to find in this example. Let me first of all read the example. An electron with charge E enters a uniform magnetic field V bar with a velocity V bar. The velocity is perpendicular to the magnetic field. The force on the charge E is given by F bar is equals to BeV. Obtain the dimensions of V bar. So let's do it. We are asked to find the dimensions of B. Either it is B bar or B, that doesn't matter. That doesn't affect on the dimensions. We have given an equation. Modulus of F bar means F is equals to BeV. Therefore, this can be written as B is equals to F upon E into V. Let us number this equation as a 1. Let us write the dimensions of known quantities. F is the force, so has a dimensions m1, L1, t raised to minus 2. E is the charge of electron. We need to write unit of that physical quantity in such a way that so it can be expressed in terms of fundamental physical quantity. We know that current I is equals to charge upon time. Therefore, to find the dimensions of E, we need to write it like I into T, where I is the fundamental quantity, T is also fundamental quantity. Therefore, dimensions of charge E are I1 t raised to 1 and V the velocity of an electron. It is expressed in terms of meter per second. Therefore, dimensions are L1 t raised to minus 1. Now, putting the dimensions of all the physical quantity F, E and V in this equation, that is in equation 1, we get I1 t raised to 1 in meter per second, L1 t raised to minus 1. So, this will be M1, this t raised to plus 1 and t raised to minus 1. Multiplication is there. Therefore, this will be cancelled. Shifting I raised to 1 and L raised to 1 to the numerator, we get I raised to 1 shifting to the numerator from denominator, plus 1 becomes minus 1. L raised to 1 shifting from denominator to numerator, plus 1 becomes minus 1. Again, here this plus 1, L raised to plus 1, L raised to minus 1 get cancelled. So, SI unit of magnetic induction is, dimensions of magnetic induction are M1 I raised to minus 1 T raised to minus 2. So, if you know unit of magnetic induction B, it is expressed in terms of Tesla. But you cannot find the dimensions from Tesla. You need to express it in terms of fundamental physical quantity. Therefore, from this equation F is equals to BeV, we can find the dimensions of magnetic induction V bar. Okay. Now let us read another problem. Nuclear radius r has a dependence on the mass number capital A as r is equals to 1.3 into 10 raised to minus 16 a raised to 1 by 3 meter. For a nucleus of mass number A is equals to 125, obtain the order of magnitude of r expressed in meters. Therefore, radius of the nucleus is given as r is equals to 1.3 into 10 raised to minus 16 meter into a raised to 1 by 3, where a given is 125. It can also be expressed as cube of 5. Therefore, putting the value of a here, we get r is equals to 1.3 into 10 raised to minus 16 into 5 raised to 3 raised to 1 by 3. So, on simplifying, we get r is equals to 1.3 into 10 raised to minus 16 into 5 raised to 3 into 1 by 3. Therefore, this 3 into 1 by 3, it will be cancelled. So, this will become r is equals to 1.3 into 5 into 10 raised to minus 16. Therefore, on multiplying this 1.3 by 5, we get 6.5 into 10 raised to minus 16. There is formula to express order of magnitude of any number like b into 10 raised to either plus or minus c, order of magnitude, and this power c is called as order of magnitude along with its sign. But there is condition on writing value of this b. Therefore, this b, what is value of b? What should be b? Then the power of 10 can be expressed as order of magnitude. B must be 0 is less than, b is less than 5. B must be less than 5. So, it is from 0 to, it is from 1 to below 5. If the number is expressed like that, then the power of 10, either it is plus or minus, that can be written as a order of magnitude. But here, looking at this point 6.5, we can round it off. It is more towards 10 than towards 5. So, we can round it off to 10. Therefore, expressing it in terms of power of 10, we can write this number as r is equals to 6.5 into 10 raised to 1. Sorry, I am so sorry. It should be 0.65 into 10 raised to 1 into 10 raised to minus 16. Therefore, this will be r is equals to 0.65 into 10 raised to minus 16 plus 1. Therefore, r will be 0.65 into 10 raised to minus 15. Therefore, here in this case, this 10 raised to minus 15. This minus 15 is the order of magnitude of the radius of nucleus. Therefore, order of magnitude of radius of nucleus will be 10 raised to minus 30. This minus 50. Now we will discuss one more problem. From the exercise of units and measurement. I'll read the problem. An object is falling freely under the gravitational force. Its velocity after traveling the distance h is v. If v depends upon gravitational acceleration g and distance, prove with the dimensional analysis that v is equals to k root of gh, where k is the constant. So we are given that velocity is dependent on acceleration due to gravity and height of the air column. So v is equals to k g raised to a. This dependence on absorbing this proportionality sign, we will write it as in terms of constant of proportionality, where this k is constant. This k can't be calculated with the help of dimensional analysis, so we'll keep it as it is. And what is our goal is to prove v is equals to k into root gh. Okay, so let us first of all write the dimensions. Velocity L raised to 1 t raised to minus 1. Acceleration due to gravity meter per second square, so it is L1 t raised to minus 2. Height h is equals to, it is in meters, so it is L raised to 1. Put in 1, put all these dimensions in equation 1. So we get velocity L1 t raised to minus 1 equals to k L1 t raised to minus 2 raised to a L raised to 1 raised to b. Therefore, on simplifying, it will be k is equals to L raised to 1 raised to a is L raised to a, t raised to minus 2 raised to a is minus 2a, L raised to 1 raised to b is L raised to b. On simplifying, it will be k, on the LHS it will be L1 t raised to minus 1 as it is, k L raised to, here power base is same, power difference, so it is L raised to a plus b t raised to minus 2a. On comparing powers of a, b, on comparing powers of L and t on both the sides of, let me number it as equation 2. So we get, on comparing powers of L and t of equation 2, we get, so let us first of all compare the power of L. So here on the LHS there is 1, on the RHS there is a plus b. So it will be 1 is equals to a plus b, that is a plus b is equals to 1. On comparing power of t, so on the LHS here it is minus 1, on RHS it is minus 2a, so it is minus 1 is equals to minus 2a. On absorbing negative sign, it will be 1 is equals to 2a, therefore a is equals to 1 half. On substituting this a in this equation, we get 1 half plus b is equals to 1, therefore b is equals to 1 minus half, that is b is equals to half. So these are two values we are getting. We are going to substitute it in equation 1, so we can get the desired equation, that is, put a is equals to half and b is equals to half in 1, so we get velocity v is equals to k a raised to half b raised to half. Sorry, I'm so sorry, it must be g and h, so this will be g raised to half and h raised to half. Therefore, velocity v is equals to k root of v to h. So this is our proof. Okay, thank you. Remaining problem we will discuss in our